Good morning, good afternoon, everyone. Welcome to today's Exploring by the Seat of Your Pants event. My name is Joe Grabowski, and I will be your host for today. We are coming to the end of October. So if you've been following along this month, you know that we have been diving deep into space exploration. So we've been talking to scientists, to engineers, even to astronauts, people who have dedicated their life to exploring what is beyond our atmosphere, beyond our solar system, and of course, inventing really cool new technologies that we can use here on Earth as well. So this is actually our last space exploration event for the month, and I'm really excited to have Wynne joining us. He is active in the developing field of planetary cave exploration. So using remote sensing technologies to detect caves on other planets and moons. He's collaborated with NASA researchers using both robotic and human exploration of extraterrestrial caves, so developing those technologies that can be used in the future. He's bushwhacked through the jungles of Belize and China, rappelled into the deepest volcanic pit of the Big Island of Hawai'i, endured the driest desert in northern Chile, and explored deep vertical caves in southern Spain. So Jut knows caves. So he does it to learn more about caves, about the secrets they contain, even finding new species in some of these amazing ecosystems. So Jut, it is so awesome to have you joining us live today. You are an Exploring by the Seat of Your Pants veteran. We always love hosting you. And the classrooms today are excited to get to know you a little better.
All right, Joe. Well, thank you so much for having me. It's a pleasure to be here and to have this opportunity to speak with you all about caves on other planets. As Joe's mentioned, I've been studying caves for quite a while, almost 20 years now. And it's taken me all over the world, and it's taken me to, or it's encouraged me to not only look at caves here on Earth, but to look at caves on other planets as well. And what I'll do is I'll go ahead and let's see here, share. I'm going to go ahead and share my screen with you all so we can start the presentation. All right. Joe, do you have it?
Yeah, we just needed to go full screen, Jut.
All right, let's do it. All right, so here we go. So as we mentioned earlier, we're looking at caves on other planets, and the way in which we're finding caves on other planets is by looking at caves here on Earth, which is much easier to get to, obviously. So first of all, my work has largely been focused towards looking at caves or looking for caves on Mars. And the first question that comes to mind is, why in the world would we want to look for caves on Mars? Well, there's a lot of reasons. First of all, on Mars, there is a lack of an atmosphere. And as a result of that, solar and cosmic radiation basically bombard the surface of Mars. And what results is everything on the surface is dead. So if there's life, or even evidence of life, we're going to find that deep underground. Also, the surface of Mars has been pummeled by meteor and micrometeor impacts. Once again, due to the lack of an atmosphere, there's no protection. Like here on Earth, we have protection of our atmosphere from, well, medium to smaller size meteors. The big ones, obviously, they've hit us a few times, and the result was not very good. But on Mars, there's virtually no protection. Also, the dust storms on Mars are immense. About every 10 years, a dust storm completely engulfs the entire planet. Pretty crazy to think about that, but that happens. And when that happens, that, in terms of equipment, that can cause quite a bit of damage to equipment. So when we think about where to put people on Mars, well, underground would be great because you would be protected from these dust storms. One such example happened this past year, May of 2018. And if you focus this is the entire surface of Mars. This was a courtesy of NASA. And you can see that this is as this dust storm is growing. That little blue dot that you see there is Opportunity rover. And what happened to Opportunity rover, as we well know, this dust storm basically resulted in the rover's death. We were unable to wake it up after this dust storm. So that just gives you kind of a bit of an idea as to what can happen to equipment when one of these immense dust storms takes place. As I mentioned earlier, best place to search for evidence of life. If life existed or exists on Mars, this is where we're going to find it. We're going to find it underground. We won't find it on the surface. Also, as I previously mentioned, it's the best place to put people for those very reasons that I just explained. And also, this is the best place to find evidence of or to find water. And as we all know, water is important because, one, humans require water. And what we can also do is we can also use water. We can break the H2O into two. We can use the hydrogen for making fuel, and we can use the oxygen for breathing. So it serves a lot of benefits to humans in terms of living on Mars, either temporarily or perhaps for a longer period of time. So what I want to do here is I want to share with you all a video that was done about 8 years ago. It was done by NASA. And let's see, here we go. I'll go ahead and play it. Can you hear it?
Space researchers consider the most likely location for discovery of potential primitive life forms. They find that prophets are all over the NASA under airborne and ground studies by invasion of detected caves on the Earth, the Moon, and Mars. Study is to learn how.
Dad, I'm wondering if you can hold the phone. Is it playing from your computer?
Are basically coupling those grounding mechanisms of current developing techniques for the
All right. So this is something to think about here in terms of when we want to figure out how best to conduct such a mission. This is one of our first steps, right? First, we have to collect the data to be able to put together a mission. But then what we want to do is we want to basically kind of storyboard this out. We want to create a path forward. And the way in which NASA and other scientists typically do that is by developing a mission architecture. And this is what we have here. You can see there's 4 components to this architecture. First is remote detection. I'm about to discuss that with you all now. Candidate selection, so finding those caves that are going to be the best candidates for exploration. And then we would move on to sending robots in to further examine those features. And then from there, the possibility would be for human exploration and use. So first, let's look at remote detection, and that's where the bulk of my research has taken place over the past several years. And first, as I mentioned earlier, what we have to do is we need to be able to figure out how to find caves on Earth. And once we do that, we can then take those techniques and that approach and apply it to looking for caves on other planets, in particular on Mars. I had the opportunity to work in the Atacama Desert of northern Chile. I've been there several times now, and this was one of our major areas of research. And what I first want to do is just show you all what it looks like when we're looking at temperatures of caves. Now you see this graph here on the bottom left of your screen. I guess it would be the bottom right of your screen if you're looking at it on the projector. And what you see here is you see on the left side, on the vertical axis, you see temperature, and on the horizontal axis, you see time. If you look at the blue line, that is the surface temperature. And as we would expect, when the sun comes up and when it gets to its hottest point of the day, typically noon, that's what you see as the point there. The coolest part of the day is obviously at night, and you see that dip. Now, if we look at these two entrances, with this particular cave, we had two entrances, a lateral entrance and a vertical entrance, or a sinkhole entrance. And what you can see here is that the temperatures of those entrances were quite different from the surface. And this is exactly what we were hoping that we would find. And what you can see here is if you wanted to detect caves using thermal imaging, looking at heat signatures, you would do that either during the hottest part of the day or during the coolest part of the day. And this is exactly what we showed when we found when we actually started looking at thermal images. Now, these are images that we took. We basically took the 24-hour day, divided it into 4 periods, late evening, pre-dawn, early afternoon, late afternoon. And what we did was we then captured thermal imagery during those different windows of time. And you can see here during the late evening and pre-dawn, when the surface is the coolest, the entrances are the warmest, which was pretty awesome. That's exactly what we were hoping to see. And when you see it, when we're looking at the hottest parts of the day, you see that it's really difficult to see those caves. So we took that information with this, looking at these actual images and also looking at the temperature data that we collected. And we're like, okay, well, these are the best times that it looks like that we would be able to find caves on Earth, and then we can potentially apply that to looking for caves on other planets. This is a vertical entrance of a cave, and this is showing here what it looks like over time. What we did was we then took a camera and we set it in front of the entrance, and we collected images every 10 minutes, which gave us 144 different images. And you can see here, as it changes with time, you can see that it becomes slightly more difficult to see that feature. At the left of this image, once again, you have the earliest part of the day or the coolest part of the day, rather, at midnight. You can see the entrance is glowing this very whitish color amid this darker surface. If you look at the feature in the bottom left of your screen here, you can see that it's much different. The surface is very hot and the entrance is very cool. That's because it was at the hottest part of the day. So taking this information together, we started to puzzle this out. We started to learn how to detect caves using thermal images. Now, granted, I have to emphasize that we're not just using thermal, we're also looking at the visible images as well, basically the photographs. So we can compare that information to the thermal also. So it's going to take a multi-image approach where we're looking at different types of imagery to figure out how best to find caves. This is another technique that we applied when we were looking at the thermal images. And basically, we can't get into a lot of detail here, but what I want to say is there's a lot of math, statistics, and programming required to do this type of work. Now, you saw from that video that what we did was we collected imagery during 2 parts of the day, at night and during the day. And you can see here in the top left, the red circles indicate where the caves are. And this was taken from the daytime imagery where the surface is glowing whitish and the caves are actually dark. If you look at the top right, you see the night imagery where you can see the images, or you can see the caves glowing white within the images. And then bottom left, once again, that is the daytime imagery. And then what we also did is we also took the pixel values for each pixel and we subtracted them from one another to create a third layer. And then we took all this information and we created these different computer models. Once again, a lot of math, a lot of statistics, and a lot of programming. But what we found out by taking this approach is this. This is one of our results. This was really cool. If you look at these red triangles here, those are what we believed to be cave entrances. Those green lines on top of them are what we knew to be cave entrances. And look at the agreement that we have here. We were actually able to find the caves using the thermal imaging, which was really cool and really exciting for us. So now let's shift our attention to looking at caves on Mars. Back in 2007, we published a discovery paper revealing the very first cave-like features on Mars, and here they are. The two lead authors on the paper actually named these after nieces and aunts, so that's why they have all these. That's why they have these names here. Now, once again, if you recall looking at those images from Earth, where we took that camera and just set it in front of the entrances, what was really cool is we saw agreement with detection times for caves on Mars. If we look at this 3-panel image here, what you have is in A, we have the visual, it's just a photograph of that one of those cave features. B here, you see it was taken at midday at 1500 or 3 o'clock Mars time. Very difficult to see that feature. But if you look at 4 o'clock in the morning, boy, look at how that lights up. We could actually see it beautifully. So that was telling us, okay, this could be a cave, but we don't know. All we do know at the moment is that it's a big, deep vertical shaft. That's all we can say right now about it, but it seems to be behaving like a cave. This was really neat. This is a high-resolution image of one of those pit crater images. You can see here that it or pit craters rather. You can see here that it has a 30-centimeter resolution, which is absolutely spectacular for looking at features on other planets. And it's amazing that we have such a high-resolution camera in operation. If we look at it here and compare it to an American football field, which is about 92 meters in length, look how big it is. This thing is absolutely tremendous. It's over 100 meters across. Some colleagues of mine developed what is called a geophysical model looking at where water ice could occur. Because remember when I mentioned earlier how important it would be for humans to be able to have access to water ice. Also, what NASA and other space agencies typically will do is they will want to, they follow the water in terms of looking for life. So if we can identify those areas most likely to have water or water ice, those would also be the best places to look for evidence of life. This geophysical model, what my colleague Kai Williams and his colleagues did in this paper that they wrote, is they identified those areas that were most likely to have water ice. If you look here and you can see what's lit up is what's identified as red, and then over here in the middle of this dark bluish color, those are the two areas that were identified as the highest likelihood for containing caves with ice within them. This is a database that was published last year identifying all the caves or cave-like features that were known to Mars, and we have over 1,000 different cave-like features on Mars to date, which means that's a lot of work for scientists to potentially do. But what I did here was I then took that computer model that Kai and his friends had made, and I overlaid those locations of where caves could occur and or where caves have been identified rather, and look at the agreement. Most of those caves occur where there could be water ice. So that was really great news for us because we know that these are going to be great targets for exploration. So now let's look at these two different possibilities for candidate selection. So we've identified using remote sensing where those caves are on Mars. The next step will be is we're basically narrowing our focus in terms of what we want to do. We're now looking at candidate selection. How would we select candidate features on Mars for exploration? And then evaluate those for both humans and for the search for life. So first, robotics. One application, as I just mentioned, would be to search for evidence of life. And then we could also use robotics and potentially drones for looking for or to examine those caves for human habitation, to find those caves that are safest and that are most optimal for placing people within them. Once again, a rover would be good for site evaluation. We could bring a rover into the entrance to look at the cave. Maybe we could bring it up to the edge of a cave and look within. In terms of going into the cave, what we call a dual axle or four-wheeled rover is not going to be great for that application, but we could use it to look at the entrance. Something else that's really cool are helicopters on Mars. Now, there's a mission coming up. They're going to be sending another rover to Mars, and it's called the Mars 2020 mission. And part of that mission is going to have a drone with it. And you can see the drone featured here in this image. Now, what the drone's going to be able to do, it doesn't have a lot of power, doesn't have a lot of juice, but what it can do is it can go up about 100 meters above the surface of Mars, take pictures, and then come back down, recharge, and then it can do it at a later date once it has a full battery charge. Now, the beauty of this is that this is basically a proof of concept for using drones to look at caves. Once NASA and other space agencies have been able to refine this technology, we may then ultimately be able to use it for cave exploration on Mars. All right, so now let's look at the robotic exploration here. In it was April of 2014, I went out with NASA JPL engineers and we field tested the world's first, the world's first running robot. And you can see it featured here. It's called LEMUR. This is my friend and colleague, Dr. Aaron Parness, sitting there with his baby. He is the engineer that designed this robot. And something like this would be the type of robot that we would actually send into a cave on Mars or on another planet. Sending in a rover with four wheels and rolling it in is not going to work. You can look right here at the entrance where I'm sitting. How would a four-wheeled rover get over all of those rocks? It ain't going to happen. So it would have to be sent in, or we would need a climbing robot to be able to navigate the rigors of the cave environment. This is another example. This is a more recent version. This is LEMUR 3, and you can see here that it's basically LEMUR 1 from that previous image on steroids. It looks a lot stronger. It has a lot more capacity. There's actually a LiDAR system on it. It can now see. There's multiple cameras on the robot, and it's actually getting to this point where it can start to collect data for an actual mission. So that's an example of the type of rover that we would want to use for both examining the entrances of caves and potentially going deep within the caves. So now let's look at human outposts. How and where would we place humans? And more importantly, once we are able to establish where we can basically set up temporary or permanent astronaut shelters, how can we work safely and effectively underground? Because working underground can be dangerous. So first, this is something I wanted to share with you all. This is our best bet for getting to Mars within a realistic time frame. We probably will be able to get there within the next 5 to 10 years by SpaceX. This is the Interplanetary Transport System. It is the Falcon Heavy rocket with their spaceship that you can see mounted on top, and that is what we would be using to get to Mars. This is an artist's concept of what such a Martian base may ultimately look like. But as I discussed earlier, what about those dust storms? What about cosmic radiation? What about meteor impacts? This doesn't look like a good place. This doesn't really make sense to me. I continue to say we need to be underground. This is an example of, this was an artist concept about 5-10 years ago of what it would be like or what it could look like to actually have a astronaut shelter underground. But if you think about it, this is a rigid-bodied shelter. It's made of some sort of composite metal, and it's going to be very heavy. So that is going to be a limitation for getting things from Earth all the way to Mars is weight. That is one of the most expensive aspects of sending people and things into space is the weight associated with it. So this is what we would probably want to use. This is called an inflatable habitat pod. This is a concept that's been advanced by a friend and colleague of mine, Dr. Pablo de Leon. And you can see here, basically, we would take it could be reduced to a very small size. You then insert it into a cave. You hit the inflate button, and then you have an instant home. Much lighter, much more portable, and a much better option in my humble opinion. Regarding spacesuit technologies and related equipment, well, this once again is an artist concept developed by Gus Frederick. You can see here that in this particular image, the spacesuit is very tight fitting. This would enable astronauts to move freely, much more easily within the cave environment. You can even see, if you look at the artist concept of this particular astronaut, you can see that he actually even has knee pads on. That's something that we wear all the time. So those are the sort of things that we would need to figure out how to do in order to live and work safely underground. Now, there was a recent advance that was released, there was a big announcement made about 2 weeks ago on October 15, where they unveiled the new spacesuits by NASA. And you can see here this one in the middle here, the white one, the red, white, and blue one, that is actually a spacesuit for walking on the moon. It is indicated that it is going to allow much more dexterity. You can move much easier wearing this than you could in the earlier versions of the spacesuit, but still look at it. I would not want to walk around in a cave with that. I certainly wouldn't want to get down on my hands and knees with such a spacesuit. It would be incredibly difficult. Also, if you think about it, this particular spacesuit has the pressure within it of a basketball, 8 pounds of pressure. So if there's a breach, if it tears, it's going to, it's going to be very ugly for the astronaut. It would kill the astronaut, and it would be, because it is pressurized and much larger, it would be much more difficult to move around with wearing such a spacesuit. Once again, something like this is where we need to be going. This is what we need to be focusing on. And not to mention, you can see here that the astronaut has a harness, or he has a rope, and it looks like, in this particular example, he's freehanding, which I would never do climbing, but this is just an example of the sort of technologies that we would need to be able to work effectively and efficiently underground. Right now, unfortunately, none of those technologies exist. Spacesuit doesn't exist, and the technologies don't exist, and that inflatable habitat pod that I just showed you all, that is in a very early stage of development. So technically, that can't even be used yet to go to Mars. So in summary, we know there's over 1,000 caves that occur on Mars, which is really exciting for folks like me that study caves on other planets, because that means there are a lot of opportunities for exploration, but we first have to figure out how to narrow those down to the best caves for both searching for evidence of life and for the best place for astronaut shelters. I would have to emphasize here that we know absolutely nothing about what it's like underground. We know nothing about the Martian subsurface. So that would be our first step, as I mentioned earlier, with robotics, to start to see what is going on underground and to be able to evaluate those features for exploration. Drones and climbing rovers are the future of planetary cave exploration. The rovers that we have been using in the past simply will not work. Also, for us to forge forward and go to Mars and ultimately establish bases there, it will require us to become cavemen and cave women once again. We will be living in caves all over again. And for us to be able to do that, we're going to have to develop the technologies, which is going to require a lot of investment of both time and money. So that's something that you all can be thinking about as you're figuring out what you might want to be when you grow up. You might very well be working on some of these projects to advance these technologies so we can get to Mars. So, are you going to Mars? That is the question that I have for you all. I would love to go, but you all are going to be the group that most likely will be forging beyond Earth. So in order to do that, I would encourage all of you all to study hard, to question everything, to read, stay fit, exercise, and make that part of your life. And with that, I can take as many questions as we can fit into the remaining time that we have here.
All right. Perfect, Jet. Thanks so much for sharing that with us. And that makes a lot of sense. We always see in movies that they're living on the planet, on the surface, but for all those safety reasons, all of those benefits, it makes sense that caves is probably going to be where people will first be living on other planets. And then I want to get a show of hands before we do questions. How many students out there, if they had the chance, how many would want to go to Mars? Let me see some hands. How many? Whoa, look at that. Pretty much everybody. Very cool.
What about you, Joe?
And yeah, oh yeah, in a heartbeat. Absolutely. All right, very cool. Well, Jet, let's meet some of our classrooms and let's squeak in a question from each of them. So let's start off with Mrs. Matthews' class. They're joining us in Courtney, British Columbia. I'm going to turn their microphone on. There it is. How are we doing, Courtney?
Good.
All right, who's got a question?
Hello, my name is Lacey, and my question is, what types of discoveries have you made in your career?
Some of your
In my career. I'm sorry, was there, I think I spoke while you were speaking. Was there something else that you wanted to say, Lace?
your most fascinating discoveries.
Yes.
Most fascinating discoveries. Oh my goodness. You know, it's really interesting with caves. There's always discoveries. Every time that I go into if I go into a cave that I've seen numerous times, or that I've been in numerous times, I will always see something that I hadn't seen before. So to me, that's exciting, because I was like, oh wow, I didn't know that rock formation was there. That's really beautiful. But in terms of scientific discoveries, in addition to this type of work that I'm sharing with you all today, I also study cave animals. And with that work, what we've done is we go in and we collect cave bugs, because we want to know first what lives in the cave, and then two, how those animals interact within the community. And in order to do that well, you need to know exactly what type of animals you're looking at. So we will identify those animals to species. And oftentimes what we find is that when we're doing that, my goodness, these are animals that have not been identified by scientists yet. So they're new to science. And through that line of work, I guess, let's see, we've identified, 10 new species on Easter Island, 10 new species in China, about 40, 50 new species from the American Southwest. And we just finished a project in Belize where I believe we have another 15 new species. So I'm getting really close to identifying around 100 new species to science. And these are all invertebrates. But to me, that's a really exciting aspect, is the ability to make real tangible contributions to natural history, where we can say, these are new, here's the names, here's the paper that describes them, and this is now part of the natural history of that particular area.
All right, very cool. Close to 100 new species. That's awesome, Jet. Mrs. Camplin's class are joining us in Guelph, Ontario, so not too far from me. Let me get their microphone turned on. How are we doing, Guelph?
Good. Peyton's got a question for you.
What things have you seen there before?
Other than bugs?
Other than bugs.
So I'll repeat it. Sorry, Jet. What other things have you seen, if anything else, in caves besides the bugs that you've discovered?
Ooh, okay, I got one. So this past summer, I was in Belize, and we were working in caves that had crocodiles in them. They were actually deep within the caves. And we found them in 3 of the 5 caves that we went to. Now, unfortunately, we did not see them. We were trying to see them by putting camera traps in the caves and these holes that we believe that they were in. But what we did see was we saw a lot of fresh crocodile tracks that were through the cave. And we were able to see that, and that helped us narrow down exactly where they were, because we could see the tracks leading into these holes, and we're like, okay, they're probably in that hole there. But that was a really cool discovery that we made. And the question that I had was like, okay, my goodness, what do they eat? Because there aren't a lot of big things in caves that crocodiles would be able to eat. So we know that the caves flooded with water a lot, and when they flooded, there could be a lot of fish in there. So, and that was their primary prey item. They're called Morlitz crocodiles. And so we're like, okay, well, when the caves flood, that's probably what they eat. But what do they do when there's no food, when there's no fish, or when fish is scarce? And we also learned that Paca use caves. They're basically these large rodents. They're about that big. And so they probably eat Paca when they don't have access to fish. But that was pretty cool. And it also, when it made you hyper aware of what you were doing, because when you're on your hands and knees crawling through a cave and you realize there could be a 12-foot or 3 to 4 meter crocodile in that cave with you, you really pay attention to what you're doing.
All right, fair enough. Mrs. Padberg's class is in Kansas City, Missouri, some grade 6s. Let me turn their microphone on. There it is. How are you doing, grade 6s?
Good.
All right.
Okay. So my question is, how dangerous is your job, the job that you're doing right now? Or since you're doing like all of this planning and stuff, like how dangerous is the job that you have?
Well, I guess it depends on what I'm doing, because I also spend a lot of time in a lab and sitting behind a computer, so that part's not very dangerous. But when I'm in the field, there are risks involved in what I do. I would be disingenuous if I said there were not. But what we do is we plan. Any type of field work requires significant amounts of time invested in the planning behind the actual project. And I also get a lot of training, and I also train to be prepared for those unlikely circumstances, rock falls or falling and those sort of things. So those things can happen, but preparation is most important, and that's what we do a lot of. So I'm very cautious in what I do, and if you plan and you anticipate bad things to happen, when you do that, then if bad things do happen, hopefully you're prepared to address them. But we do spend time rappelling into caves. We do spend a lot of time on rope. So there's that aspect that has a risk associated with it. And then obviously being underground where rocks could fall on your head, that wouldn't feel too good. And that could happen as well. So, I guess those are the sort of things that we are aware of, and those are the sort of things that we are very cautious of as well.
All right. That's, I'm a scuba diver, and that's our philosophy, is the more you plan ahead of time, the less likely you're going to run into issues. And of course, lots of training, that helps too. San Antonio, Texas. Mrs. Derelict's class is joining us. Let me get their microphone turned on. How are we doing, Texas? Oh, it's a nice big group in Texas.
Hey, y'all.
Hi, I'm John. I have a question. Do some of us have to live on Mars, or all of us? Or do we not have to live on Mars?
We don't have to live on Mars. I would say first and foremost, we need to do a better job of taking care of this planet. And I don't think we should think that we can move to Mars and everything will be okay on Mars. That's not going to happen. we will have a very long virtual umbilical cord connecting planet Earth to planet Mars. That's just the way it's going to be. We will most likely into the very far future be reliant upon Earth for resources, for food, for those sort of things. But yeah, exploration of other planets, I think that is the natural progression of things for humanity. When exploration started, and European exploration started writ large, if you will, during the 1500s, during the late 1500s, that really opened up the door for, what is on the other side of that hill? What is beyond, what is on the other side of that ocean? That's what we did. That's what we do as humans. So it's natural for us to say, okay, what would it be like on Mars? Let's see about living on the moon. Then we can go to Mars. Then maybe we'll go further.
All right, great question. Let's see, Mrs. Conyers' class, fourth graders in Pennsylvania. Let me get their microphone on. How are we doing, fourth graders?
We have a fire, Joe. We have a fire. We have to do a fire. My name is Devin.
All right, who's up?
I didn't hear any of that. Unfortunately. Joe, could you repeat it?
Yeah, I think, are you close to the microphone? We heard the cheering, but we can't really hear the question.
Sorry, we are wondering what inspired him to start exploring.
Was it what inspired Jut to study caves?
Yes.
Yeah, beautiful. Okay, Jut.
Oh, that's a cool question. So, where it started for me when I was your age, I was very curious about the natural world. When I was a little boy, I grew up on an island off the coast of South Georgia, and I spent so much time in the woods, so much time in the marshes, on the coast, on the beaches, just looking at animals, and I'd take animals home and I'd put them in enclosures and I'd watch them and I would observe them, and that's really where it started for me. And I think I'd always wanted to study nature ever since I was a little boy. As I got older, I kind of lost my path for a little while, but I always knew that I wanted to study nature. And when it finally came full circle and I became an adult and realized that was what I wanted to do for a career, I was studying, I became a wildlife ecologist. I developed an interest in bats, and bats led me into a cave in Belize. That was my very first professional experience looking at animals that occurred within caves. And my goodness, when I went into that cave for the first time and started looking at the animals that were in it and just observing everything, and the water hitting falling from the cave ceiling and landing in the pools, just the noise that the caves made, I was like, wow, this is awesome. And I knew that that's what I wanted to do at that point. It was pretty much as soon as I walked into the cave, I was like, yeah, I want to do this as a career. And so slowly over time, that became more and more of a reality.
All right. Well, it's a very lucky thing, Jut, when you find something you're passionate about and you get to turn it into a career. So I think that's pretty good advice for the students, is find what you're passionate about and find a way to make it your career, because then it doesn't seem like work anymore.
Exactly. You find what makes you happy and do that.
All right.
That's my recommendation.
Perfect. So we have one more class to visit. They joined a couple minutes late, but Mrs. Wu's class is here from Penticton, British Columbia, some grade 7 students. Let me see if I can turn their microphone on. How we doing, BC? There they are. All right.
What education do you have to be able to do your job?
Well, good question. But that's a bit of a loaded question, because it depends on where you are and what you want to do. If you want to become a naturalist, we have the ability right here to observe nature and to be able to make those observations and to be able to start puzzling that together. And if we have the curiosity, we can pick up field guides and start to read field guides to learn more about animals, to learn more about nature. And it's kind of learning by doing. So that is certainly an option. So you all can become junior scientists just by being curious and getting out there. But in terms of what where I am now and how I got to where I am, well, I went all the way through a terminal degree. I got a PhD in ecology. So there are really two routes to take. The folks that I work with in other countries, they don't always have educations like we do here in Canada and in the United States. They learn by doing, by getting out there and doing the work. And they're some of the most amazing people that I've had the opportunity to work with, were folks that learned by being out in nature rather than, sitting with their nose in a book.
All right, Jet, I think I'm so glad you brought that up. That's something that comes up regularly in our events, is there is no right or wrong way to get into science. There's all different paths. Some people start studying one thing and change to something completely different and unexpected. So there's lots of ways to get involved in science, lots of things to explore and discover. There is no one path that everybody should follow.
Hey, Charles Darwin didn't have a PhD in ecology, nor did Isaac Newton have a PhD in physics.
All right. Well, listen, boys and girls, thank you so much for another awesome event. Your questions, as per usual, were awesome. It's great to see you thinking and learning. And Jut, thank you so much for wrapping up our month of space exploration. It was great to spend some time with you. And we're going to have to get you down the road to cave biodiversity action. All
right. Outstanding. Thank you very much, everyone.
All right. Last thing I'm going to do today is turn on all the microphones. Good job, everybody. You guys are the best. Thanks so much. We'll see you next time.